Today, we are continuing our unit on factoring quadratic expressions, and we're talking about a specific type of quadratic called a perfect square trinomial. Before we begin that, we're going to talk about squaring a binomial. So in our warm-up, this first one is x minus 5 squared. So remember that square power means multiply it by itself. So x minus 5 times x minus 5. So we would distribute the x times x would give us x squared, and then we take x times negative 5 to get minus 5x. Next, we distribute the negative 5. Negative 5 times x gives us negative 5x, and then negative 5 times negative 5 gives us plus 25. Next, we would combine like terms. Negative 5x minus 5x would combine to be negative 10x. So after distributing and simplifying, we get x squared minus 10x plus 25. On the second one, we have 3x plus 4 squared, so I'm going to write it out as 3x plus 4 times 3x plus 4. And then distributing 3x times 3x would give us 9x squared. 3x times 4 gives us 12x. Then we distribute the 4. 4 times 3x gives us 12x, and then 4 times 4 gives us 16. We can combine our like terms. 12x plus 12x becomes 24x. So both of these end result products here are called perfect square trinomials because they can be written as the square of a binomial. So square of a binomial, we have the squared exponent, and then inside the parentheses there are two terms. So if you can recognize that a trinomial is a perfect square trinomial, then you can use a shortcut for factoring. So this is just a way to most quickly get to the factored form. So what you're going to look for is, are the first term and the last term a perfect square? You ask yourself that first, or you recognize that first. After recognizing that the first and last term are perfect squares, you think about what is the square root of the first term, what's the square root of the last term. If you were to multiply those square roots together and double it, would you get the middle term? If so, you have a perfect square trinomial. And if you do, you factor it using this pattern. So now, how do we go from this to this? First, the first term in your parentheses will be the square root of the first term. So notice how we have a squared here, but just a here. So to go from here to here, we take the square root. Next, we have plus or minus, and then over here, plus or minus. That just means whatever sign is here, you'll have the same sign here. And then the last number in your binomial will be the square root of your last term. Number one, to factor that, first you might notice, okay, 9x squared, that's a perfect square. 16 is a perfect square. So that's the first step, is to notice that you have perfect squares for your first and last term. Now that doesn't mean it is for sure a perfect square trinomial. So what I like to do is I write the square root above it. So the square root of 9x squared is 3x, and the square root of 16 is 4. Then in my mind, I multiply these together. 3x times 4 would give me 12x, and then I double that. So 12x times 2 is 24x. So if I can multiply these together and double it, and I get the middle term, then I know it's a perfect square trinomial, which means I know it factors into the square of a binomial. So this is how we use our shortcut. Since I already wrote whatever I wrote up here, the square root of 9x squared, that will go in the binomial. And the square root of 16 will be the last term in my binomial. And then whatever sign I have here will be the same sign in my binomial. You can use your traditional methods for factoring that you already know. That will still work. This is just a method it's a shortcut to get you to the answer as fast as possible. All right, so in number 2, we got to first recognize x squared. That's a perfect square because the square root of that is x. And then 9 is also a perfect square. The square root of 9 is 3. And then in my mind, I multiply x times 3, which would be 3x, and then I double that. That would be 6x. So since I can multiply these together and double that product, and I would get the middle term, it fits that pattern for being a perfect square trinomial. That tells me it will factor into the square of a binomial. And then I would just put the terms I wrote above, go into the binomial, and then same sign as we had in the middle. That factors into x minus 3 squared. Number 3, the first term, 25x squared, if we took the square root of that, we get 5x. And then for the last term, the square root of 1 is 1. Multiplying those together would give us 5x. Double that, we would have 10x. So our middle term is 10x, so it fits our pattern. So we know it will factor into the square of a binomial. And then what goes inside the binomial are the terms we wrote above with that same sign that we had in the middle. Thank you for watching.